Okay guys, so let's go over the drill here. The top part, no equation, so we are just factoring, so we're going to go from standard form, which all these are in, okay, into the intercept form, which is the form with the parentheses, okay? So that's our goal right now. If there's two terms, guys, I mean, no matter what, how many terms there are, you have to see if you can make the number smaller by dividing out a GCF, a greatest common factor. That's the highest number that'll go into both of these. So in here, the highest number that'll go into 8 and 12 is 4. And then they don't have the variable in common because the 12 doesn't have an x, so you just bring that out. And then when you divide by that GCF, whatever's left over stays in the parentheses. So 8 divided by 4 is 2, and you put the x. Negative 12 divided by 4 is negative 3. And there is your factored form. And you're done. Now number 2, again, look for a GCF first. Well, the a value is 1, so there's definitely not going to be any kind of greatest common factor between the three numbers. So now, since the a is 1, I'm just going to look for two numbers that add to negative 2 and multiply to negative 15. Pretty straightforward there. Negative 5 and positive 3. And then you're done. Then here, any number that goes into 3, 5, and 12, well, there aren't any, so since this is 3 terms, it only works with 3 terms, okay, and when a here is not 1, I'm going to do that t method, and we're always still adding to negative 5, and you'll see where that comes in. But first, let's do numbers that multiply to 3, so 1 times 3, and numbers that multiply to 12, okay, so I always think 4 and 3. Let's see if this works. 3 times 4 is 12. 1 times 3 is 3. Is there any way 12 and 3 will add to negative 5? No, no way. So, okay, cross these off. Switch the order of what I just put. So I'm going to put the 3 here and the 4 here. 3 times 3 is 9. 1 times 4 is 4. They can add to a negative 5 as long as the 9 is the negative and the 4 is the positive, right? So that means when you did 3 times 3, that means the negative goes here in the top, and then the positive goes down here with the 4. And the x's always go in the left column. And you put your parentheses straight across. So then when you write your final factors, x minus 3 straight across, and 3x plus 4. And there's your answer. Number 4, we have 2 terms. The a value is 1, so there's no GCF, right? Nothing that'll go into them. But now look, these are both perfect squares and it's subtraction. So I'm going to do that special rule, difference of squares. The square root of x to the second power is x. And the square root of 9 is 3. And the rule says one must be a positive and the other must be negative. And there, you're done. Looking at number 5. Number 5, the numbers are 2, negative 9, and negative 18. There's no number that goes into 2, 9, and 18. So that's why it's 3 terms. I'm going to jump right away to the t-chart. So I'm going to start with numbers that multiply to 2. So 1 times 2. Numbers that multiply to 18. Okay, I'll try 2 and 6. I'm sorry, 3 and 6. So let's see if this works. 2 times 3 is 6. 1 times 6 is 6. Didn't work. No big deal. Let's try switching the order. 6 and 3. Okay. 2 times 6 is 12. 1 times 3 is 3. Now remember, we're still trying to add to the negative 9. That's how I knew 6 and 6 weren't going to work. But 12 and 3 will work as long as the 12 is negative and the 3 is positive. So 2 times 6 is negative 12. 1 times 3 is positive 3. So then the x's go here again. So here, I'm going to do, okay, x minus 6 and 2x plus 3. And there's your answer. Number 6, if you take a look here, okay, 10, 80, and 150, 10 will go into all of them. So you need to divide them all by 10 first. That is your GCF, and that goes on the outside. You can write it here and have it divided by 10, but you need to put whatever you divide out, that greatest common factor has to go out in front of your parenthesis every time. So let's see, that would make 1x squared minus 8x plus 15. then you look at your answer and you say, okay, can you break down what's in the parenthesis further? Well, in this case, okay, the now new a value, ignore the 10, is a 1. So our ultimate goal here is we don't have to do the t-chart to test this. We just try to come up with two numbers that'll add to -8 and multiply to 15. Well, I got -3 and -5. And then where does the 10 go? Right down in front. And there is fully factored form. Now notice there were, again, no equations in the top part. All I wanted you to do was factor it. So now these are not solving. The bottom set are solving. And remember, when you're solving, what that means visually is that if we typed each of these in our calculator and we saw the graph of them, it would be the x-intercepts that we're finding, those zeros, solutions, roots, okay? So let's take a look at number 7 here. So I have D. Now again, there's only two terms. So, this has a value of 1, so there's no GCF. But except they have a letter, so really the GCF can be a variable. So we're going to actually bring the GCF out as D, and we're going to divide both of those by a D. When we do that, you're reversing the distributive property. So if there were 2 here in the problem, like D squared, divided by D makes 1D left over. And then -2D divided by D, well, that would make -2 here. And now that we're solving, don't forget your equals 0. Now here, everyone always gets confused because you don't know what to set equal to 0. Well, the rule is you always set what your factors are equal to 0. And you have 2 factors here. We have D, so, okay, D equals 0. Well, that's one of our answers already. You don't have to solve anything. D is going to be 0. And then the other one, D minus 2 equals 0. So D equals 2. So there are your 2 x-intercepts, also known as solutions, roots, zeros. This one's a little easier, right? So factoring the a value is 1. So numbers that add to 6 and multiply to 5, well, that's just 1 and 5. Now, again, you don't stop there with just the parentheses because when it's solving and you have the equal sign, that's where you're finding the x-intercept. So we're going to set these, and the only way to do that is to set these equal to 0. So C equals -1 and C equals -5. And those would be your solutions, x-intercepts, roots, zeros. So here, okay, let's see, no GCF between 3, 10, and 3, so I'm going to do the t-chart. Numbers that multiply to 3, 1 and 3. Numbers that multiply to 3, I'll switch the order because, again, I know I want to add to -10, so I'm going to do that. And the reason why I knew that would work is because 3 times 3 is 9. 1 times 1 is 1. So when you add them up, they'll make -10. Remember, as long as they're both negative, so that means the negative goes here and the negative goes here. And you put your x right there. So in factored or intercept form, it looks like this. But we haven't solved it. To solve it, you have to set both factors equal to 0. So x minus 3 equals 0. So one of them is x equals 3. And then 3x minus 1 equals 0. So the other one must be 1/3. You add the 1, you divide by the 3. Now, if you take a look at the last 3 here, they all have one thing in common. They are not set equal to 0. So you need to bring everything over to the side with the x squared. Okay? So I'm going to rewrite this as x squared minus x and minus 30. So I could get 0 here. So I subtracted them from the right side to bring them over to the x squared. You have to set it equal to 0. So now, the only 2 numbers that will add, let's see, because I'm just going to do this like say is 1, add to -1 and multiply to -30 are -6 and 5. So x minus 6 equals 0 and x plus 5 equals 0. So I get x equals 6 and x equals -5. Let's see here. So again, you want to subtract the 15, so bring it over here. So it becomes a negative 15 so that there's 0 left on the right side. So there's no GCF because nothing goes into 2, negative 1, and negative 15. So I'm going to do the t-chart because the a value is something other than 1. Numbers that multiply to 2, 2 and 1. Multiply to 15, it's really just 3 and 5. So let's try that, or 5 and 3. Let's try 5 and 3 in that order. So 2 times 3 is 6. 1 times 5 is 5. To add to negative 1, the 6 should be negative. So I'm going to put a negative here and then a plus here. So then, go straight across, 2x plus 5 in parentheses, 1x minus 3 equals 0. So you set both factors equal to 0 again. So I get, subtract the 5, so x equals negative 5 halves, or negative 2.5, and x equals 3. So you can see it pretty much is the same process each time, guys. You have to be able to factor in order to get these x-intercepts. So, okay, subtract the 50 from the 4, because again, it has to be set equal to 0 first. Okay, so, oh, well, this, I guess I didn't have to do the t-chart, right, because this is a 1. So, numbers that'll add to 3 and multiply to that. Well, we have 9 and 6, I think is the main ones. So I'll make it as x plus 9 and x minus 6. So then x equals negative 9 and x equals 6. So the rest of class today, the first thing you're going to do is finish your puzzle piece with your partner. Okay, so I have them saved. If you are absent, you're going to grab a sheet of notebook paper and you're going to join a partner group. Then after you finish that, you're going to make sure to re-paper clip your puzzle completed with your notebook paper behind it, names on everything, turn it in, okay? And then you're going to start the blue scavenger hunt. If you look around the room, you will get a sheet of paper and you and your partner are going to start. It's just like before. The problems are at the bottom, solved by factoring still, okay? And then you go find your answer, which will be on the top of a different problem. Whatever you do not finish of the scavenger hunt, you will get about 25 minutes, give or take, in class, maybe 30 on Tuesday when I see you guys, but then it will be collected for a grade. So make sure you're working and staying on task. So all of this is to review solving by factoring. Good luck.